This video looks at what happens if you are organizing elements where you have some elements that are the same, which is a real life scenario that happens. Maybe you're looking for socks and you've got 4 black socks and 8 blue socks, which makes 12 socks altogether, and you're trying to figure out how many pairs you can make. So if you have n objects containing A identical objects, B and C groups of identical objects, your number of permutations is given by this expression here. So n factorial, so your total number of objects, divided by how many repetitions you have. So example 1, in how many different ways can the following letters be arranged? So in the word dab, we've got 3 letters, each of them are unique. We would have 3 factorial, no repetitions, gives us 6 possible permutations. Now we're going to look at the word dad. We've got 3 letters, and one of them is repeated twice. So we've got 3 letters, one of them is repeated 2 times, which is going to give us 3 factorial divided by 2 factorial, which is just 3. Now we're getting a little bit more complicated here. We've got Dwayne "The Rock" Johnson, and let's highlight some of our common letters here. So our first one is N. So you've got 3 N's. You should be looking for other common letters. Our next one is E. So we've got an E, and that's it. Next one is an H. So we've got 1 H in the, 1 H in Johnson. And then the last one is an O. We've got an O in rock, and then 2 O's in Johnson. So on the top, we need how many letters we have all together. So that is not the right pen. So we've got 20 letters all together in his name. And then we're going to divide by the number of repetitions by group. So our N repeats 3 times, our E repeats twice, our H repeats twice, and then our O repeats 3 times. So we've got our N, our E, our H, and our O. Evaluating that on your calculator gives you a lot, 1.69 times 10 to the 16, which is a huge number of permutations. The last one we're going to do is Bieber. So again, I'm going to highlight our common letters here. So we've got a B, 2 B's, and then we also have 2 E's. So we're going to start with our total number of letters on top, which is 6. And then we're going to divide by the number of repetitions that we have. So our B repeats twice, and our E repeats twice as well. Evaluating that on your calculator gives you 180 different ways those letters can be arranged. Example 2 is a team finishes a 21-game season, so that's your N, and they've got 12 wins, 7 losses, and 2 ties. So those are your groups of repeated events. So just like in the letters, we're going to start with our N factorial on top, and then we're going to divide by our number of repetitions. So our number of wins, number of losses, and then number of ties. Evaluating that on your calculator gives you 503,880. The last one, how many numbers greater than 3 million can be formed from the digits 1, 2, 3, 3, and 4, 4, 4? So numbers that are greater than 3 million are either going to have a 3, in front, or a 4. Those are your only possibilities. So we can find the number of possibilities for each of those outcomes and then add them together to get our total number of permutations. So with a 3 in front, we would have 6 factorial, so that's our N value, divided by the number of repetitions in our remaining letters, which would just be our 4s. So that would be 3 repetitions of that 4, which is going to give you 120 possibilities. With a 4 in front, I would again start with my total number of possibilities here, and then I'm going to divide by the number of repetitions. So if I'm using the 4 in front, I've got 2 3s left over in my remaining spots, and I also have 2 4s left over. Evaluating that on my calculator is going to give me 180. So my total permutations is going to be 120 plus 180. There are some other ways to think about this. See if you can come up with a different way to find the total number of permutations, and let me know.